In this video, we will cover transformations of trigonometric functions. Before we begin, we're going to revisit some of the terminology for trigonometric functions. So the amplitude is the height from the center of a sine or cosine function to the maximum or minimum values. The period is the length of one cycle of the function on the x-axis before the function begins to repeat itself. The center is the mean value of the sine or cosine function, and the phase is a horizontal shift, a translation of the wave. Remember, a vertical dilation has a scale factor of k. In terms of a trigonometric function, this is known as the amplitude. Note that tan does not have amplitude. If k is greater than 1, the function is stretched, and if it's between 0 and 1, the function is compressed. If k is a negative, the function is reflected in the x-axis. We also have horizontal dilations. Remember, this is your a value, and it has a scale factor of 1 over a. In terms of your trigonometric functions, this is your period. If a is greater than 1, the function is compressed horizontally. If a is between 0 and 1, the function is stretched horizontally. And if a is equal to a negative, the function is reflected on the y-axis. The period is the speed that a wave goes through a full cycle. We also have vertical translations. Remember, this is your c constant, and it dictates the center of a trigonometric function. If c is greater than 0, the center has been translated upwards. If c is less than 0, the center has been translated downwards. We also have horizontal translations, which is dictated by the constant b, and this is known as the phase of a trigonometric function. If b is greater than 0, the phase shift is to the left. If b is less than 0, the phase shift is to the right. We will now answer some questions. On your screen, you can see y equals 5 sine x. We need to sketch this graph. So the purple line is your original sine x wave. The 5 out the front is a scale factor for a vertical dilation, which means we are going to be going up and down. The wave is going to be stretched. It also dictates the amplitude, which means we will be going 5 positions up from the center, 5 positions down from the center. Our 5 is here, and our negative 5 is here. Next, we have y equals cos x minus 3. The minus 3 is in the C position, which means it is a vertical translation, which means we need to move the original cos x, which you can see in purple, down 3 positions. So its new center is at negative 3, which is here. So our transformed function is as shown. Next, we have y equals sine x over 2. Now this is a horizontal dilation because it's connected with the x. And we know it's going to be compressed along the x-axis. It is also our phase shift. Period shift. So we know that we're going to be going through the waves slower. In this case, because our period is 1 over 2, we're going to be taking double the time to get through it. So instead of getting through one wave, we will get through half the wave. Next, we have cos x plus pi. Now this is our phase shift, and it is a horizontal translation. Because it is plus pi, we know the whole wave is moving to the left pi. So essentially, this point is now here, and this point is now here. Alright, that is a pi difference. So our wave looks something like that. So remember, if your change is inside the brackets here, we know that is going to be a horizontal translation or a phase. To recap the video, remember amplitude is a vertical dilation and it controls the up and down. The period is a horizontal dilation. The center is a vertical translation and the phase is a horizontal translation. I also want to go back through some of the key terminology here, such as amplitude, which is the height from the center of the function to the maximum and minimum values, or the peaks or troughs. The period is the length of one cycle of the function on the x-axis before the function begins to repeat itself. The center is the mean value of a sine or cosine function, and the phase is the horizontal shift or translation.